Normally, the water treatment program involves using filters to remove foreign matter for source water, which may be raw water, effluent, or as tertiary treatment, sewage treatment, or sewage treated from STPs. These filters generally consist of layers of media like anthracite, coal, sand, and gravel, which work together to trap particles. While letting clean water through, however, over the period of time, the filter media can become encapsulated with organic and inorganic, and the result is the decrease in filter effectiveness. When water turbidity increases or clarity decreases and water flow through the filter slows down, a filter backwashing process may be manually or automatically triggered. A backwash, which is a standard and necessary part of any water treatment process where we send a stream of water back through the filter and filter media in order to dislodge filter contaminants so they can be removed from the system. However, this process also uses a great deal of energy and clear or filtered water. Add to this, the system downtime required to clean and reset the filters is also high. And you quickly start to understand that filters that need to be cleaned more than average can result in huge expenses for utilities in terms of water and electricity. Backwashing regularly can increase the near-term effectiveness of a filter over time. The filter media gets covered or encapsulated with organic and inorganic matter that limits its effectiveness in water filtration, that we can see regularly especially in sewage treatment plants. Even with more frequent backwashing, this is especially concerned in areas where water is scarce because more water is then used to backwash even as much as filter produces in a day, wasting a precious resource, and not to mention the loss of revenue from the filter. That encapsulation in turn means that the filtering effectiveness decreases and the time between backwashing sessions or run time decreases as well. The results are slow water treatment filtering systems that end up costing more and more to operate. In some cases, tunneling occurs where water finds its easiest path through the filter bed, forming channels that allow the water to pass through unfiltered. This causes the water quality issues, and in some cases, breakthrough can occur, sending significant amounts of unfiltered water into the distribution system. And in addition, in some cases, the filter becomes so clogged that they stop operating altogether, or worse, cause back pressure in the clogged under drains. This means that attempts to backwash through under drains may result in blowout and cause the entire filter to be taken offline for servicing and reconstruction, which can last for several months. Unfortunately, some operators tend to pay attention to filters only when they fail. This can result in costly emergency repair situation and often ends up resulting in total replacement of the media. But it also includes the transportation of new media in addition of disposal of the older media. So this increases the labor cost, this increases the downtime, and also includes the cost of the processing, the administrative cost, the transaction cost. This process can be even more expensive if the replacement needs and takes place during high water demand periods. Problem can be solved through chemical treatment solutions like what we have EFICLEAN SM, specifically the formula to remove matter that encapsulates filter media, all while the filter media remains in place. The water level in filter media is brought up to cover the media, allowing the formula to penetrate deeply into all layers of the media, then starts to break down the organic and inorganic contaminants within the media. The encapsulated media is revived with minimum disruptions and also cleans under drains and other hard to reach part of the system. This also removes the scales and organic buildup from the filter valves and other parts of the filter system. So try this. We want you to be successful. Best regards from Justcom Solutions Private Limited.